space meets your smartphone, and machine connect across oceans, deserts, and everything in between what you can think of. This session, D2D and M2M, that is direct to device and machine to machine, Satcom unpacks a bold transformation underway in global connectivity. With the help of 3GPP standardization, satellite links are no longer restricted to ground terminals or specialized dishes. We are now witnessing the dawn of direct satellites to smartphones, communication, and satellite to IoT device integration, unlocking massive potential in logistics, disaster response, agriculture, defense, and global coverage, whether it's connecting sensors in remote oil fields, enabling messaging in zero coverage zones, or powering smart agriculture where cellular networks fade. D2D and M2M Satcom is redefining access, reliability, and resilience. Guiding us through this transformative discussion is our moderator, a distinguished leader in India's telecom standards ecosystem and a champion of innovation, Dr. Vijay Madan, advisor and mentor at TSDSI, that is Telecommunications Standards Development Society, India. I welcome you, sir, on the stage. Thank you so much, sir. Joining him are three pioneering voices from the device and satellite industries. I welcome Mr. Manmeet Singh, Senior Director at Qualcomm, a company at the very heart of mobile technology, chipsets, and now direct-to-satellite innovation. Thank you so much, sir. Next, we have Mr. Satrio, I hope I pronounced the name correct, Director of Technology at PT, Pasifik Satellite, Nusantara, Indonesia's leading satellite operator and a regional force in hybrid satellite mobile solutions. Thank you so much, sir, for joining. We next have Mr. Viabhav, who is Vice President, International Sales at Hughes Network System India Private Limited. With that, I invite Dr. Madan and our esteemed panelists to the stage to lead us into truly connected future where every device, every sensor, and every human is just one satellite link away. Thank you so much, sir.
Hello, am I audible? Okay, thank you very much. So we have an interesting subject. So many interesting subjects are there for 3 days, thanks to India Space Congress and our friends SIA-INDIA. I'm very excited and very happy to have to moderate a given session where there is some competition and some thought for the future. I have my distinguished colleagues. We had some discussion how to run this session and what might interest you also. So fortunately for you and for us, we do not have any presentation. So we'll be chatting here and asking your indulgence as well. So basically today's subject has, of course, it talks about machine to machine. It talks about device to device, device to cell, and all those things. But basically, we are talking about technologies which are ubiquitous, places where terrestrial networks have some issues. So whether satellite can take that space. And in that race, perhaps, some competition also emerges, where both possibilities are there. There's a satellite, there's a terrestrial, not only complementing, but perhaps may or may not be competing at a given point of time. Basically, direct-to-device is the issue which allows unlimited, unmodified IoT, et cetera, such as asset tracking, and as was mentioned in the context of this session, that we are looking for where terrestrial systems cannot reach. And in maritime, when you are driving and you have some gaps and spaces where terrestrial is not able to serve, so satellite comes into picture, basically. So also direct to cell, people are talking about where we have texting, calling, light internet browsing, and handset. So exactly D2C, for that matter, would directly replace terrestrial mobile devices, but D2D may need either some modifications on the satellite side or on the device side with some embedded chips and so on and so forth. So satellite-centric design and custom-centric design for what you call device-centric design. These are two thought processes or two types of technologies which will solve either of the problem. We can focus something on satellite-centric design, where satellites are purpose-built to connect with existing IoT. So when we do that, there will be costs. There will be other issues also. But when we have device-centric, then devices are embedded with chipsets to enable them to communicate with existing satellite infrastructure, for that matter. So costs, you have to compare whether it is satellite adjustment costs are more or device adjustment costs are more, and also that. So these two types of things may be discussed in this particular discussion. And then we have a role of standards, as was mentioned. We are 3GPP, and they are also trying to define from release 17 onwards on NB-IoT, LTE-M, and LTE Cat1, etc. So, for example, AST, Space Mobile, Link, and Starlink, etc., are of category 1. And then we have another category, NB-IoT, Viasat, Iridium, and these are all type of users or type of service providers, satellite service providers. So, therefore, key players in the entire D2D ecosystem could be LTE-based D2D and also NB-IoT-based D2D, and so on. These two are differentiators between two types of service providers. Like Iridium is the second category and all that. Challenges there are in D2D about spectrum allocation, because it's always have been challenges. Demand by satellite providers on one side, the terrestrial providers on the other side. And then when new technologies are evolving, new waveforms are also getting developed in the area, so that supposing in terrestrial, we are talking of dynamic spectrum, and as 5G and 6G are evolving, the 6G is basically a use case driven. The network is flexible in giving KPIs. In some cases, low latency may be required. In other cases, massive MIMO may be required, and all that. So therefore, the issues are how to dynamically use or how to fixed allocate such spectrum slices and other things and all those things in the plan. So we have talked about regulatory complexity, therefore, once spectrum comes into picture. We have high capital investment for D2D and all that. So unless everybody starts using the same system, the cost cannot come down. Then monetization issues for service providers who are terrestrial audio, they have advanced to 5G and 6G, but they are not able to monetize those things because critical applications have to be defined. The critical expression, what is for 6G, what is for 5G, and what may be for 7G, and so on the one hand. On the other hand, the issues of latency and so many other issues of complexity of mass device development and all that are going to be there. So in India also, they have tried BSNL with Viasat to provide some D2D. So some updates may be there on that. So then machine-to-machine satellite communication is basically see, issue here comes is authentication, authorization, security, uh, and also where systems are overlapping, issues may be coming of handover. Is it possible in satellite and normal terrestrial system, or people will like who have made a lot of investments in either? So what type of possibilities are there? So this will be yet another discussion point. So, for example, in remote locations, operational efficiency, fleet tracking systems, marine systems, and all that. Sometimes in some of those satellites, it's becoming a compulsion, and also a very, very good system. Not only a compulsion, but offers very great services there. But some areas may be very heavily populated, even in even urban areas. You may have quality of data issues, quality of call issues, quality of downloading issues and all that. Whether one can support each other or it is not possible to, that it is only exclusively one system or the so that's the outlook, trends of convergence of terrestrial as well as satellite networks is happening, and there are some, in 3GPP also there are some discussion and all that. But unless mass adoption or numbers are very high, either system cannot be cost effective or cannot be used by many, and therefore monetization is always a problem. Our service providers who are in terrestrial are worried about monetization. We claim that we have, in 5G, we have rolled out the system very fast, but where are the critical applications, whether it has served some critical use cases, and it is like health sector, like defense sector, like other sectors which are very, very important, smart sectors, verticals, smart cities and all that. How much they have gained from that connectivity and all that. So 3GPP release 17 and 18 have been talking about for UAV support, emergency communication, and IoT optimization. Emphasis on hybrid network support or something like it. These such discussions are also there. So what will happen ultimately, IEEE is also joining 3GPP efforts where they can mull together, they can discuss together such issues and all that. But still, consensus and all these things have to come. EI, for example, power, spectrum, spaces, spectrum sections, such discussions are also in the progression. So therefore, I think I'll finish in the next 1 minute. That is 5G systems functions on board in M2M platforms. This also is an idea. Last but not least, NR-ITN will evolve as RedCap and all that. So 3GPP support to RedCap Hughes in releases 17 and 18 is already being discussed. It is worth noticing that NTN-based massive Internet of Things use cases using narrowband and LT machine type also is happening and known as IoT NTN for that matter. Similar to this, 3GPP has discussions onwards, release 17 to now release 19, 20, 18, such things and all that. So such contemporary technologies will continue to be discussed. But what overtakes when massive use of each technology is there and all that. So these are some of the questions I propose to discuss with specialists here on my left. But maybe a couple of minutes you can speak about it, and then we'll start with some questions. I'll pose it to you, and then some questions to the audience.
Thank you, Dr. Vijay. I think you covered a very broad spectrum of the discussion points. I'll say, I think 2-3 points which we can highlight here is, one is cost. Of course, the cost comes down with mass adoption and standardization. So as the things standardize, there will be mass adoption. To start with, I think satellite-related direct-to-device or machine-to-machine is going to serve some niche areas where it is needed. For example, global logistics, it's a very big demand for this. And then there's emergency services. We have already seen very, even if there are lives saved, even there are few, in the cases of earthquakes and all, it has saved the lives. So that is very critical. And then given that the technology is in your device, then it becomes even easier because you can use it when it is needed. IoT application, of course, logistics is one of the things, and the remote areas. Defense is another application where you need this. So it will start with those applications, and then slowly it will go and become more standardized, and the cost will come down. Now, whether it can, whether it will be complementary to terrestrial, we still think that it will be covering the areas where the coverage is not there, and especially in the geographies which has these issues. And it will start from there. Eventually, you will see, like, for example, when the coverage is there, but due to certain climatic condition, terrestrial networks can go down, and then it becomes very important, this whole stuff. Security and others are definitely challenges because jamming and all is possible. End-to-end encryptions are very important for your messaging to any kind of application. Your gateways are very important, which geographies they stay. A lot of countries are debating that also, whether the gateway should be within the geography of the country or outside. So all those are the issues which will be slowly sorted out. And I think then there's other aspect of providing broadband, but which is KU bands and all. That's a separate, which is definitely going to impact connectivity in the remote areas. So that is definitely a use there. So I think, and then of course the, your satellite connections in the airplanes and all. So these are the areas where definitely niche areas where it will pick up, and then slowly it will move to other areas. I think as long as we stay with the standards, which we as a Qualcomm, we took a decision that we will go with the 3GPP standardization, because we think that will gain the mass adoptability rather than going with very different solutions and a very diversified ecosystem, which generally does not work that well. Yeah, thank you.
Thank you, Dr. Vijay Madan, for the opportunity to be a panel, and thank you very much to India Space Congress and SIA for allowing. Thank you for Dr. Vijay, and thank you for Indian Space Congress and also SIA for allowing us to be participate in this panel. So, from our perspective, based on our experience, we see that end users doesn't see whether it's from terrestrial to satellite or other technology to be connected. Now, whether it's to direct to device or machine to machine or Satcom, we see that cost is a very critical thing that we want to maintain. And we see that with 3GPP, whether it's really 17, 18, or 19, we see that integrations between cellular and satellite and other technology becomes a reality. So meaning that interoperability between networks becomes ubiquitous. Now, we see with all the services, whether it's a direct device, machine to machine, does it add additional value for them to participate in these systems? The way we look at it, for direct to device, is people willing to pay $1 more to get more coverage, more services? What value do they see to have that? Because the way we look at it, COVID brings us experience that we can work everywhere, whether it's to houses, homes, wherever in the world we can work and we can coordinate everything. So that Pandora box has been open, and that demand will always be there for future generations. Now, with machine to machine, with what Qualcomm has done, every devices now can receive 3GPP release 17, 18, and 19 immediately. We see that agriculture in Indonesia becomes very, very critical, because with some investment that they do for each plant or each plantation, can they get additional yield, 10%, 20%, 30% yield? That becomes very critical. And also, we see that in certain areas, you are only able, with using certain amount of land, can you get more yield? That's where our connectivity and analysis, and I think with 6G and everybody is thinking combining AI with this network, that becomes a very different ballgame the way I see it. Now, a lot of industries are looking for that efficiencies, whether it's through direct-to-device, 5G, 6Gs, or whatever, to with the satellite standards right now. So the cost, everybody is trying to maintain the cost, but then based on our experience, we want to make sure that what we do, what system, that engineering that we do, gives additional value to our customers. Because I think now we're seeing the world is already known. So meaning that once the world already known, we see that what kind of efficiency they can get based on whether it's geographical, whether it's based on sovereign system, or based on certain systems, which they have a very limited amount of capacity and capability. So for us, at that time, then spectrum becomes critical, because then your device requires spectrum, your machine-to-machine requires spectrum, and how do we interact to the satellite spectrum and the terrestrial spectrum, and how we work together, because each country has their, Indonesia has a USO fund, I assume India has also a USO fund that came from the terrestrial and for all operators, which are satellite and everything. So how we manage that and how we coordinate, how we coexist, because at the end of the day, the way we look at it, again, connectivity has to be ubiquitous, whether it's satellite, terrestrial, as long as it's connected, providing value. I believe that market will grow and those demands will still grow. That's from our perspective.
Well, if you have seen the, if you had seen this program before, I was not on this panel, so I was just recruited. I'm trying to gather my thoughts as these learned gentlemen have been speaking. Let me introduce myself. I'm Viabhav, Magow, and I work with Hughes. I've been with them for the past 26, 27 years. To give our perspective as a company, we've been involved in various aspects of this. In fact, today, Hughes EcoStar is locked into building and developing a direct-to-handset or D2D business. We've made it pretty public. I think it's information out there that we would like to launch a LEO constellation, a global LEO constellation, to provide direct-to-handset, direct-to-device services. So we've pretty much going through all of these deliberations as a company that Vijay ji spoke about at the start of this session. From what has been experienced thus far, so we have a service today as called as EcoStar Mobile, which works over Europe. It's a geostationary satellite, works in S-band, and it uses the LoRaWAN protocol. And what Hughes does is that we work with IoT companies, people who provide sensors and IoT solutions and software, and they take a module from us. So it's a small little module which they can plug into their sensors. Some of the examples and applications I can just quickly share. There are companies who are doing soil monitoring for agriculture, etc., moisture monitoring. There are companies who are doing monitoring of large electricity distribution poles. Over the years, these start having a weakness in the structure, so you actually have sensors which continuously monitor the vibration of these towers, and then they alert these electricity distribution companies that there is a problem, etc., and all of these. So there are many places and applications which, if you really start digging, require connectivity in places where there is none available. So this chipset that we have with EcoStar Mobile actually works in LoRaWAN and over satellite S-band. So if you have a campus where you have LoRaWAN working, the IoT signals and the service can be obtained over LoRaWAN. And if your coverage area requirements extend beyond that campus, so let's say you're putting up a LoRaWAN radio and let's say it covers 20 kilometers, 25 kilometers, whatever the distance of LoRaWAN campus you're building, and then but you also need some devices and some coverage outside that. So as soon as you put the device outside the coverage, it will take the S-band coverage from EchoStar Mobile and it will communicate with that, with the same software and the same sensor. So, and then of course the provider would, instead of using the LoRaWAN protocol over terrestrial waves, is using LoRaWAN over satellite, S-band. Now we can even fit IoT, NB-IoT on our solutions. We could actually run this on NB-IoT as well. But then when we were building this system, we had this debate about should we use NB-IoT or LoRaWAN. But the chips for NB-IoT were so expensive that if we went to these people who build these sensors, they would just not be able to buy them in large numbers. So today we are able to build these chips in a very small cost. And for example, they're anyways putting, most of these people, if they want LoRaWAN, it's the most popular IoT standard today, LoRaWAN. It's low on power, it uses very little battery, it's all the positives, it ticks the boxes. That's why it's the most adopted standard. But, so they already embed LoRaWAN into their product. So what we tell them is that instead of buying a system which only supports LoRaWAN, you add our chip into it, our circuit into your sensor. And then you need to take another $7 antenna and hang it as the S-band antenna. That's the additional cost you have. And then you can also say that today, if you don't have coverage for LoRaWAN, you can do it. But if we went to NB-IoT, it was very expensive. So it was just not, so the adoption is not there. But if tomorrow NB-IoT chips become cheaper, we can easily pivot our service and we can also offer NB-IoT. So today, we can saddle both. That's how we've done it. So this is our experience, and we're doing lots of applications, we're doing tracking, etc. and all, but that coverage is geostationary. It is based in Europe, and obviously geostationary has its own, the orbit has its own associated issues, costs, etc. because you can only provide so much of spectrum and power. Going forward with the LEO constellation, just a few days before, we launched a set of satellites which we have been calling LIRA, so we've invested in those. These are low Earth orbit satellites that are built on the same spectrum, and they'll be orbiting the Earth. And while we are running these applications with EchoStar Mobile on a geostationary, we want to port them onto LIRA as well. This is still not a global constellation as we're planning. This is partially going to cover. Right now, we have plans of launching 4. We launched the first one. It wasn't very successful. The second and the third, they've already started communicating, etc. So I've heard from my management that things are all looking good. So we'll start porting our solutions onto this. The next step for us would be to go into full-fledged, deployment of our global constellation, etc., which we are working very hard on, and hopefully our organization would be able to come up with more public information about this and can share. But some of the concepts that Vijay you shared, we're happy to talk about that and exchange on this panel through whatever we do.
Thank you very much. Hello. Am I audible now? Yeah. Thank you very much for your comments and initiating this panel discussion. Of course, interactive panel discussion with the audience also, because smiles I have started seeing from service providers of terrestrial already, and they have been talking about monetization even of terrestrial. So how does such things happen when you have complementary, supplementary and competing technologies, perhaps in future? So, couple of questions are coming to my mind, and I'll speak the questions first, and you can take whatever you like out of that. What is the trade-off of latency, bandwidth, availability, power, ease of use, mobility, support? These are the things which require as a KPIs between satellite tracking edge devices and satellite D2D using mobile smartphones. So this is one. On the complementary, is it only complementary? I'll repeat for your benefit also.
for ubiquity or overlapping as well with terrestrial systems at places and at domains, verticals and so on. And people have cited about agriculture, people have cited about defense, he's talked about emergency communication and so on. Are some mergers between D2D, people are claiming D2C, D2D, are there mergers possible, or as open standards going beyond 3GPP and all that, considered amongst these groups, then IPR issue, of course, will come when you have such technologies and all that. Then are these special waveforms, as already 3GPP has started thinking about 6G and beyond, whether they will need special waveforms for performances and also catering to various types of use cases and so on, and also networks optimization and other things. What are the trade-offs between expensive satellite settings on one hand and cheaper device on the other hand, costly device versus existing satellites and all that, whether in GEO, LEO, whatever range it is, or even high altitude platforms and so on for that matter. Then applications, up and downlink issues, when you talk of machine to machine, it's not only down the line, it's communication between the machines and all that. So uplink, downlink, all those parameters are also to be discussed. So applications of ubiquitous system for essential critical systems or unreachable areas, you mentioned all of you. Types of visual cooperation between MNOs and satellite service providers. Any updates on BSNL, Vijay with somebody, or in the audience also has got. They have tried chipsets availability and all those things, and possibly mass adoption. And if satellite D2D, D2C can be a disruptive threat any time to terrestrial systems. So these are some of the things which come to my mind. Last night I was thinking about flow of our discussions. You can pick up any one of them and speak to the audience. Okay.
Okay. So let me address the question on latency. Yeah. So latency and bandwidth. So and the cost also. So latency has few parameters which we see. One is whether you're communicating with a LEO satellite or a GEO satellite. So that is a parameter which gets added to. The other thing is where the antenna is placed in your device. That also has a factor in there. So if you're designing a device which is pretty much meant for, grounds up meant for satellite communication, I think you can take care of latencies very well. But if you are designing a device which is a mobile phone, for example, and you're putting D2D service, of course the mobile form factors are very important, and you cannot disturb a form factor of a mobile for those additional antennas and all, or placement in a way which is suited for the satellite communication. So sometimes you have to take a call and put the antennas where it is not perfectly suited, but it is okay. So there the latencies gets added. But I think the main stuff is when you acquire the satellite. So if it's a LEO satellite, it's always moving. The direction is not clear where it will be tracking. So that is the software application which you put, that matters a lot, which can guide you to quickly connect to the satellite. So you might have seen in certain implementations which are already launched, there are pretty good tracking applications which tell you where to point the device to acquire the satellite. So that is most important thing. But it's good that in a mobile phone you have the UI interface, so you can take care of that. In M2M kind of devices where you don't have it, you definitely need to take care of the antenna in a way that it is right in the right direction. Because you cannot move those devices, those might be mostly fitted devices, and they are very, you don't have any UI interface to check anything. So that way latencies can be taken care with either software implementation or antenna placements. Then comes to costing. I think the good thing is what we have seen is when you start standardizing the stuff, so what are the costs in a device? So you have modem, but given that it is standardization, so we always support every latest release of 3GPP, and when we start supporting every release and the features,
the deltas are not that high. Of course, we need certain RFF components like some band pass filters and all, which adds to the cost, but they're very small costs which are added on the SoC side and the RFFE side. So I think, and they will also keep coming down. So I think cost, even in what we know of the cost few of the devices which are designed on Qualcomm-based M2M chipsets, they are not that expensive. The costs are more related to the end-to-end services because you need to have end-to-end service to do that. You just cannot send a satellite and then get application and what to do. So you need to have a platform, cloud, everything, and that is where the cost gets added. But as you see, now the cloud costs are coming down. Everything is, as mass adoption happens in those areas, so the overall systems cost will come down. But certain applications like logistics tracking, especially shipment tracking, they are pretty much, the deltas are not that high, but the benefits are pretty high. Similarly, for our emergency services or an emergency application, if you need to use it, and if you use it and saves life, I think the delta is worth paying that delta. So that's what I think as of now the situation is. But overall, the costs are already, from the device perspective, we can tell that the costs are already, the deltas are becoming very small, and within few years, we will not see that big deltas at all.
So, according to you, this question of time, and you are very stressing that in any case, emergency communication, your costs are not that important because mission is very important when you're talking about emergency services, saving lives and other things and all that. That's a very good argument. Now, actually, there could be other techno or regulatory or commercial challenges which we have been discussing about. And also, if you are with 3GPP and all that, examples of 5G NR new radio have come up over Rio, for example. Progressive 3GP releases. With all that in background and also complementary, supplementary of D2D, D2D, what do you think how the technical, regulatory and commercial challenges are going to be resolved?
So, the way I look at it, because each communication will always be based on how much link budget or power they can transfer. Right? Your device are limited to 200 milliwatts, and your satellite, whether it's LEO, GEO, you have very limited bandwidth to do downlink and uplink, which limits what you can do until the technology or the standard has been improved. Now, with that said, the way we look at it, to get a better coverage on services, whether it is to the logistics, machines to machines, and then security-wise, to ensure that whether we move to different orbits or different networks, interoperability and encryptions, everything will come into play. Regulation-wise, it's going to be challenging because I think with LEO you're covering basically the whole world, while now I think every government and every country would like to control what they can downlink and uplink, especially in certain times, in certain areas. So there are some challenges that it has to be addressed, whether through control of the government and also understanding the spectrum that is being utilized for those services. We see that still is a challenge in depending on the government, right? The Indonesian government is trying to open up such technologies for device, direct-to-device, machine-to-machine, whether it's using for terrestrial, whether it's using the satellite. But we also see that the demand to control that services is also very, very real as well. So it's challenging in terms of regulations, and we believe that satellite and terrestrial require some guidance from the government, also that we see that moving forward, that can become very, very ubiquitous as long as we have support from the government.
Thank you very much. I think a couple of words have been used by everybody. Cost and moving forward. So therefore, there are such technologies, such applications, some use cases, deployment of such technologies over and above each other. There are still parts of thought and time will tell how it gets synchronized and all that. So you talked about the possibilities of this thing. Now, you was also mentioning that if somebody finds that such spectrum or something is not available now, or such connection is not available, then he switches on to some other listing and all that. So, do you think there are handover issues or quality of experience issues or quality of service issues, and how handovers will be possible unless everybody unites together, satellite, terrestrial, and everybody, and also wireless technologies about low I talked about, what IoT.
So I think just to demystify and to answer his question, the first thing is that with the release 17, 3GPP has really opened up NT and NR to allow satellite to be part of that. So it really means that all of this inherently within the 3GPP definitions takes care of all of the latencies, etc. and all that. So we don't really have to really worry about it. The question really then becomes is that once you operate over satellite, what spectrum would you want to use, right? So let's take the simple example which we all will understand, which is the handset. So right now, of course, we're talking direct to device, but let's just shift it to direct to handset. That's the first example, and then you can extrapolate from there very easily. So direct to handset, today, if you want to use your phone, this phone only receives an INT waveform, which is a mobile, what waveforms mobile network operators use, and it uses frequencies which are licensed to mobile network. And this is the reason why, if you look at any of the D2 edge providers, AST networks, you look at the Apple service, you look at Starlink talking about the services, and T-Mobile just recently announced that they started operating services with some 800 satellites, which is essentially Starlink. So all of those services are going to use IoT. So which means that at any point of time, when you are within the network, the cellular operator has to set aside some spectrum which will then only be used for satellite access. Or you say that if I stumble across from my network, I go outside my network there and I don't have any service available, which means I don't have a roaming partner, I don't have any international telecom operator with whom I have roaming access. Let's say in the middle of the ocean, as a simple example. Then I would be able to connect using the satellite network, because this is the INT signal which I'm using. So the challenge with the INT signal that you have today is that obviously there's a lot of money involved in it, telcos pay a lot of money for it, and there's a whole debate about how much you will be able to monetize the INT signal with the satellite service, because would so many users actually pay for emergency services, etc. So today, Apple is free. Like they're saying, okay, you'll be able to text, send a message wherever you are in distress. You're not really paying for it. So the question is, if you start charging for it, would people pay? So I think these are the challenges the industry is grappling with. We talked about cost a little bit. On spectrum side, therefore, you see in release 17, 18, and 19 now, more spectrum has started coming to this, to D2D or direct to handset. So the first is either S or L band. So you mentioned Inmarsat and all of these other companies which are using L band. So they started now looking at their spectrum being available for D2H. The challenge you have on that spectrum today is that there's no one single owner. There are too many owners. The ownerships are distributed across the globe amongst different people, so they have to come as a consortium together and agree. The other is S-band. So S-band is another spectrum which can be used. So if you are within the IoT space and you are using any of these spectrums, like L-band or S-band, then you can very easily switch to those. So those will come very quickly because that's release 17. Release 18 and 19 also got KA and KU band into it. So KU band came now, which is the recent release, and then before that was KA band. So that's what earlier was mentioned by Manmeet that broadband can be possible. So those are traditional applications which Hughes does today, VSATs, where we use Ka, Ku band, and you can start putting chips. Hopefully Qualcomm will start supporting that in time to come, and you can probably use those chips in these places. So, so when you look at coverage and you fall out of coverage, that's one way of doing it, that's the IMT way. The other way of doing it is that you support S-band and L-band. When you get chipsets, these handsets very soon, I think 2026, by that time you start actually having handsets which will support release 70, which means that you have LN S-band. By the way, S-band is not new. The Chinese already support it. If you have Huawei phones, if you go to China, there's a Tiantong service which is available, which is a geo service. And in Tiantong, if you're outside of the coverage of China mobile, etc., you can actually communicate using the satellite, which is an S-band service. But it's narrow band, you can basically do some basic services. Yeah. So that's how you basically do. I don't think the concern about handovers, etc., is there. Essentially, the service is nothing different than how it works today. It will go to from the base station, it goes to the 4G core or 5G core, and the handover takes place. So from a user experience perspective, it will be very transparent, and it will be the same when you move over to the direct-to-device space. So most of the direct-to-device cases are going to be static. There won't be really mobility involved, maybe in maritime and for asset tracking, etc. You have handover issues and all of those. But largely the architecture is the same. The call will originate, whether it's data or whether it's handset, it will go into a 5G core and it will get handed over into the net. So that part I don't think, we don't see any challenges. There will be a lot of POCs that, and KPIs you'll have to develop with mobile network operators to make sure that the two systems are in sync with the KPIs. Absolutely. Before you take it to public. But I don't think a user would actually ever experience it.
Yeah, that's right. Thank you very much. So I think we have now some discussions amongst ourselves, and three parts come. One is the user. He needs quality of experience, quality of service, and he wants not to pay any tariffs for that matter or something like that. Depending, but verticals, yes, of course, the healthcare, agriculture, defense and all that, they have to pay some cost, not ordinary. We are not talking about consumer for that matter. And second thing, which is monetization, whether people are already, the terrestrial people are saying that tariffs are so low that we are already able to monetize or something. Would you like to venture into all those things and all that, or satellite to take over and these things. And thirdly, which I believe is regulation, also costs, everybody has spoken. It depends upon how usage will come and all that. So we all agree, of course, that at least complementary satellite will serve, but also possibility of some other areas which are still to be discussed for the use cases are concerned, which are, and also can we synchronize the KPIs of terrestrial system, demand for use cases versus, because the use case remains, use case wants same KPI, whether it's satellite, it doesn't care whether I get signals from satellite or whether I get signals from terrestrial. But whether my use case is being served, whether I'm paying low cost. On the other hand, the service providers, of course, will talk about qualitization and all that. One more thing about ubiquity is not just ubiquity is connectivity, but ubiquitous society, where there is a social responsibility of the government also to serve unserved areas, to serve such people who are not connected and who could be productive and useful, can be brought into a win-win situation both sides. For example, in a given site, satellite signals can be used to train nurses for health sector or some local government, rural people to be productive and then get low tariffs or something like, or subsidized tariff. So there has to be public-private partnerships or social governance as well as commercial issues and all that. So with that, I now, a couple of questions can come from the audience. Thank you very much. Yes, you can start.
So So I'm Vikram from COAI. Is there a case for a HPUE? See, T-Mobile, because they got 600, and the challenge is not from the signal from the tower to the UE, but from the UE to the tower. Yes. So is there a case to enhance coverage? Because now it is limited because of regulation of 2 watts, right? So that's one question, globally in one issue. The other is how do you handle in-building? In-building delivery. So,
Okay, that's, I think, a very good question. And I think we have a man ready to answer your question. Because I also talked about uplink, downlink information and UE to that back down. Yes. And other questions.
So, if I may answer your question, uplink is going to be very critical because whether you use different modulations, different things, because your chipset or direct device is limited to 200 milliwatts because susceptibility rate to head or bodily fluid. So now, meaning that certain amount of capabilities are going to be limited when you do to LEO or GEO, meaning that I think in Apple phone, if you're outside of coverage, you can only do text messaging for uplink. And I think in LEO, you are very limited to certain text. I think managing expectation is one thing because everybody expects that with a direct-to-device ubiquitous connectivity, they can do uplink videos, they can use Netflix and other things. Those kind of things has to be managed because the technology is not there today. I assume with 6G, you're able to push more power or have more encryption or have more compression so that those things can be managed based on the uplink availability on the device. Now, in building, I think in building would have to be a terrestrial system is probably much better now. So that's where the satellite and terrestrial would have to work together because at the end of the day, whether it's satellite or terrestrial, they still want to have the customers as their own customers. They're not moving to other networks, they're not moving to other systems because your services is with them. So the way I see it, technology, there are still some hurdles to be managed, but I believe with 6G's and capability to direct certain bandwidth to certain users, certain use cases, that will come in handy and that will enable more capability and more applications to be utilized.
Yeah, so definitely, I mean, this is satellite for a reason. You need line of sight, so there's no way limiting use cases of this to work. You're really looking at somebody who is in the outdoor, has clear line of sight to the satellite, and only then the service really be available, whether it is B2B or direct to handset. Current utilizations and the way applications are going to be based, I think the early part of the technology and even monetization of these networks is not going to be possible if you are only going to be able to do voice. There will be about some amount of data that will be had. There would be some level of interactivity, but obviously you can't expect this to be having very high speeds at this point in time. I think as the technology will mature, as platforms will mature, and we start seeing more monetization of this network, just as how 2G, 3Gs and 4Gs grew in terms of capacity and utilization, this technology would also catch up. But it will always remain to be something which would not be the mainstay of networks. The mainstay of networks would be right at the top fiber. Mobility will always be terrestrial mobile. And this is an NTN for a reason. It's not something which I think cellular operators need to worry about. I think the way this will always work is, and envisaged is that a cellular operator will have a roaming arrangement with a platform provider and will have some sort of a roaming arrangement where his subscribers can roam on to a satellite coverage, either for data or for voice calls. So it's going to be very symbiotic in that sense. Commercial models are still being worked out and how how you can monetize this. Today, initial adoption, etc., and all obviously free services, emergency services. This is what we will tend to see. But over time, I think maturity will come in all in all areas and applications.
Thank you. Any other questions on the audience side? So it appears that there's no hand. There is one. Yes, please. Can you use the mic?
As you said, there is a chipset. And is this chipset output of that, is it at the baseband or is it at the high frequency when you are uploading it to the satellite?
Can you repeat?
You have got a device and the device is connected with your chipset. And this chipset takes input from the device and connects it to your chipset. What will your chipset do? Means will it take the data at the baseband 70 megahertz, or will it have a interface at the L band which will connect it to your uplink? And what's the kind of arrangement you have for connecting to the satellite?
Yeah. So see, the chipset, when we call about this, there is a baseband which is modem, and then there's the RF part. So that's a total piece together. Of course, the baseband needs to have all the support. And then what you need is the band pass filters for L band or S band if you're communicating with LS band. If you're communicating with IMD bands, which are inherently supported in the mobile phones. Though that's a very challenging stuff as of today. We talk about that when it comes to NRNT and all, and 3GPP is trying to sort it out. But T-Mobile is one which we always talk about on that, but I think Vikram pointed out that's a separate frequency, 600 MHz, which they were not using that. To be very true, they were not using that band in any of the terrestrial communications, so they carved out that band for this thing, which is not the case of most of the operators worldwide. They don't have bands lying which they have bought it but never used it. So that is a very separate case. If you have to use the same bands which you are using, it is going to be a very big challenge. Yeah. So the LS is good. So you just need the RF bandpass filter. So those are there. You need an application. So how you communicate with the satellite, you cannot communicate the same way as terrestrial. Terrestrial, you are always connected. You can be pinged. Okay, you can be pinged by the network. Network knows where you are, and you can always send the stuff. How satellite works is that if you do that, the power challenges if you are always doing it. So it is more of, as of now, that's why it's limited to text applications and all. Because what you are doing here is, when you are sending, then you are communicating. At that time, you start reaching the satellite. And at the same time, you start pulling if there is something available to you. So that's how you manage downlink, uplink, because you need to manage the power. If you're doing a mobile phone, and especially in the emergency, you don't want to lose your battery while doing an emergency message. You need those battery. So that's the challenges which are addressed at the software applications level, that you don't communicate with the satellites always and don't drain your batteries. And rest of the circuit, modem RFFE is in place. Most of the times, even L band is 1 to 2 gigahertz, SS to 4 gigahertz. So those bands are actually there in any of the latest devices. If you see, they are there. The band pass filters are also there. So it's not like a very big addition to the devices when it comes to hardware.
There was one more question, last question from this side. Can you use the mic? Can you come here this side, because you are hidden by this podium?
Yeah. My question for the panel is relating to the direct-to-cell issue that Viabhav spoke about. We have about 3 lakh Indian seafarers, and I'm part of the maritime industry myself, and I'm working on Starlink-based geo services. My question is, I read the T-Mobile service that Starlink is tied up with. So how soon do you reckon that will be available, and will there be a viable option for the maritime sector, because there will be a huge amount of takers and it will be a game changer. So I'm curious to know, in terms of time frames and if at all available, the costing factor on that.
So that's very interesting to hear about and also to answer. But the question is about timelines. For example, terrestrial timelines for 6G and up to 2030 onwards and all that. So what's the synchronization of timelines of this case?
So, well, the current service, if you were expecting that IND would be available, like was mentioned, the T-Mobile service is on a very specific frequency. So if you are within Indian waters, then Indian laws will apply, where the frequency is really not licensed today. So that's the reason where regulation starts coming in. So there are two dependencies in terms of timeline. First of all, the systems have to be. So today there are lots of other platforms like AST, etc. Many other people have said that they'll start providing direct to handset. Many of them haven't got into a stage where they are either fully funded or they don't have full global coverage. For us, we envisage that it would be probably somewhere closer to 2028, 2029 kind of time frame by which we would have LEO constellation in orbit. And it also jives with the fact that we want the standard to be supported by the chips. So Qualcomm and Samsung and all of these guys have professed that they will support all of these standards. So even if you want seafarers, you want them to have a handset in their pocket which will support it. You can't expect them to have a separate device which will now support communication with the satellite. Right? So it has to be the same. It has to be the same device. So both of them are hand in hand. I think the one which will drive is going to be the availability of the chips, because that will become mass availability. So as more and more handset users flip their phone. So typically today the global average is that within 2 years users are flipping, especially smartphone users are flipping their phones. So once they start changing the phone, they go to the next model, they will start getting release 17s, release 18s and supports. And then they would have the ability to be able to latch on to not only IMD, but platforms where you have non-IMD spectrum also available on them. And then it becomes a reality. If you are looking at IMD spectrum, then it will be probably your local telco who would be the one who will come and offer that service to you. And it will depend on whom they tie up, how big that coverage is, etc., where your seafarers are going, are they in Indian waters or it's international waters. But you would definitely need a true global constellation to be able to support it for, by and large, everybody in the maritime. So I think timelines in reality would probably be 2028 to 2029 kind of time frame, mainly because of the adoption of handsets.
Thank you. I think it's time to conclude and I can take signals. But to sum it up, when I thought of this panel discussion, something was coming to my mind was whether devices will become affordable at any time or not, or possible at any time, with chipsets and other things, and also constellations getting ready and all these things. Perhaps the time will, it is in foreseeable time. And also the cost, as you are saying, is will not be that expensive as it is being talked about now. So mobile handset is going to really convert it to UE, actual UE, or like a small pad or something like that, which serve both purposes and all purposes for everyone. Thank you very much. I think we conclude here, and I hope you enjoyed this session. Thank you, my friends.
Thank you, Dr. Madan. It was a very interesting session and I'm sure the audience must have enjoyed. May I request audience to please be seated for another 2 minutes? And I'm sure they must have their key takeaways, and I personally enjoyed. Really, this is something very interesting topic to research upon. So, may I request you, Dr. Madan, to felicitate our panelists with the memento. Mr. Manmeet Singh, Senior Director at Qualcomm. Mr. Satrio, Director of Technology at Pasifik Satellite. To Mr. Viabhav Magow from Hughes. May I also request Mr. Sudhir Gupta from SIA-INDIA to come and felicitate our moderator. Thank you so much, sir.